Hello everyone. This is the continuation of our liver function test analysis dashboard. If you have not seen, please watch the first part where we explained it up to albumin versus ALP chart, and because of some editing mistake, rest of chart, how to create these rest of chart, it was not captured. So in this part we will explain and you will understand how can it be done. So we created a simple scatter point or a scatter chart. In a scatter chart, you can find out relationship between two numerical values. For example, albumin and ALP. These are different vitals that will appear in your blood test report or in someone's blood test report when it will be done for liver function test. Here you can see we can see some red dots, we can see some blue dots. So how it comes is, let me show you in a separate chart and then it will be easier for you. This is what we discussed earlier also. So you create a scatter plot and drag one numerical field into x-axis, whatever you feel independent, and if you want to compare its effect on this particular field. So based on some domain knowledge also, you can see what type of fields do have some kind of effect on the other field. But when you will drag these two numbers here, we will just see don't summarize. We will just use don't summarize. Okay. And when you use don't summarize, it will show you that albumin in gram per deciliter, when it is increasing, you can see there is some sort of increment in ALP, at least from initial points we can say that. Now if in legend you have a categorical field, because in the first part I explained that is healthy is our target field, it is yes or no, 1 or 0. So what we can do, we can drag that as a legend and then it will show you where that healthy range is. So is healthy 1. So if you have to be healthy, you have to be in this range, right? After 4.0 and before 4.607 here, and below 150 for ALP and above 100. So you can see what is that particular small area where most of the healthy people's data is. So that's how you can create a scatter chart. And in order to use it in this way, or in order to color it in this way, you can click the chart, you can go here, you can select markers, you can select this shape. For your colors, you can, like blue and this is selected, you can select red color and blue color. Of for blue also you can select any shade. Okay, so this is how you can create that. And for your title, you can go into the general setting of your visual, and here you can write whatever title you want to write. And here also you can select a color, make it bold, align it to center, and then you can resize your chart in such a way and place it here, right? This is what we have done. Extra thing that we always do is, it is not necessary for you, but in general we can go to effect and we can enable some visual border and shadow. Okay, this will create this type of effect. If you don't want border, you can just disable the border and you can do it like that. So now this is how this type of chart can be created. You can choose the color theme accordingly, but I have just shown what how to do that. Then you can create one copy of it, and in that copy the second parameter that we will analyze is ALT versus AST. So there is some ALT value, some AST value. So you will just replace these parameters. Okay, you will just put ALT here. So ALT in x-axis, AST in y-axis. Say don't summarize, say don't summarize. Okay, and this is showing more linear trend, and when ALT increases, it also has a direct kind of effect on AST. But here you can see those people who are healthy is 1 according to data. Like, this should not be considered as some kind of medical advice, but we are just doing it as per data, and this is particularly for data analysts who are trying to learn Power BI. But in actual data sets, after discussing it with doctors, you can verify this as well. But here you can see where most of the healthy people are lying when it comes to ALT versus AST, right? Similarly, we can create another chart here, and in this chart you can see we have direct bilirubin versus is healthy. Now for direct bilirubin, so let's get rid of this and let's create a stack column chart. So we can create a simple stack column chart. First let's get rid of all of this, okay, and create a stack column chart whenever we have to show distribution of a data. So direct bilirubin we can add directly in x-axis, okay, because it's a distribution chart, and in y-axis we can see how many total records do we have. And to calculate total number of records, we have created a simple measure. So in modeling tab, we can go and create a new measure here, and in the new measure you can type name as records, and the function that we are using is count rows, and the table name that we are using is LFT. So you can put that number of records here, okay. This will create a distribution like that. So here you can see in the distribution we have this. So we have created a group here. So suppose you want to reduce the number of bins that are shown here. So for that what you can do, so we can click here and we can create a new group. In your new group you can go to create bins. Let's say I want to show total 10 bins, okay. So from here you can create its distribution, because minimum value is 0.03, maximum is 0.28. Let's say this time I am going with 0.5 bins. So this is creating another 5 bin chart, right? So we will just add it here and you will only see 5 bins here. This is another one which has 10 bins, okay. So now we have 10 bins which are by default also, and then in legend you will just drag is healthy, and now you will have this, right? You will have a chart. What this will help you understand, this is a single variable. So if bilirubin value is less than a particular value, you can see we have more healthy people there. For values more than this, like for values more than 0.8, we have more unhealthy people. So this way you will be able to see distribution. In the similar way, we have done it for total bilirubin, okay. So we have created a group of total protein, sorry, so this is going to be total protein, okay. So this is, we are just going to put total protein here in title. So let's correct the title. So this is total protein versus is healthy. How to do that? Just create a copy of it, and in that copy just replace this with total protein group. In this group, if you will see, you have created a group with bin counts 10, okay. So this is going to show total protein versus is healthy. Let me create more area here, and this way you can create that, okay. Just a copy of previous chart, and by just replacing the variable, and you can change the title by the way to total protein is healthy. This is records by is healthy, like how many people are actually healthy. So for that we will create a copy and we'll just change it to a donut chart. We will replace legend, we will replace details. In legend we will just put is healthy, and this will show us how many people are actually healthy, okay. Then we have total bilirubin versus is healthy. So in the same way, like we have total bilirubin here, we create a new group, and in that new group you can decide how many bins do you want for the entire range. Bins are these different bars that we have, right? So we create a simple copy, and we just replace it with total bilirubin. Okay, so if you will do that, you can see if you will not use the group, you will see so many bars. If you will use the group where we have 10 bins, so it will be easier for us to see the distribution. For example, if total bilirubin value is less than zero point 0.2 in this data set, all of them are healthy. Even in 0.33 range also, 90% of them are healthy, right? So this is how you can see another variable. Similarly, we have created this scatter plot just like above for total protein and total bilirubin. Remember, we have to use don't summarize in these scatter plots for total protein versus indirect bilirubin, and legend as it healthy is healthy, and indirect bilirubin versus is healthy, and number of records on y-axis. So whenever we are doing distribution, we are putting number of records on y-axis and legend as our target field, that is healthy. This is an optional gauge chart. So in a gauge chart, just like your uh, you know bike meter or something, it is showing. So here in value, we have put average of albumin. Then in minimum value, we have put minimum of albumin. So when you will drag albumin here, you will be having options to select their different functions. So we select average as our target value, main value, minimum value is selected as minimum, maximum value is selected as maximum, and target value is selected as target albumin. Now what is target albumin? So we have manually created a target albumin value of 4.5. So by just doing a Google search, a preferred optimal albumin level is typically within normal range. It is 3.5 to 5.5. So we have selected it as 4.5. You can select anything, and you can see that overall average is how far behind the ideal average, and this will help us in analyzing that. Now as a filter, you can use these simple slicers, and in these slicers you can put whatever you want. Like for example, when I explained this, when I created this video, gender I put as slicer. Okay, so we can just drag gender here, and here also we can go in slicer header, select a particular font color. If you want to select red color, whatever you want to select here. For your values also, you can select a different font color, make them bold, that's your choice. You can also go to general tab, and in effects you can enable its shadow, so you can do that. This image that I have, this image is from Canva. So you can go and insert tab and insert an image here. So I created this image, or it was there in Canva, so I just downloaded it and put it here. For heading, you already saw how to create heading and this, and when you will apply these filters, you will be able to see, for different cases. So in case of female, what are the different ranges for different type of vitals here. For male, what is the difference? Because in, it will be depending upon gender also. So for female it is 4.25, for male it is 4.15, and similarly you can do it for other vitals also, like we have done for albumin. You can do some research and find out what is the most optimal value for total bilirubin, what is it for ALT, AST, and you can create those kind of gauge here to put, and so that people can see how far or behind or how closely is their own data to these at these normal ranges. So this was another part where we try to explain how to create these different charts, because one of the someone mentioned in comment section that this video was incomplete. So now it is complete, and I will provide you link of that first video in the description and this second video in the description of that first video. So try this. If you still have some questions, please ask them in the comment section. Thanks for watching. Please subscribe our channel, like this video, so that we can keep producing more educational content like this for every one of you.